So let's go through the basics of logic. We can think about logic as being statements about propositions, such as Obama is president of the USA, or Obama is the leader of the USA, or Dhoni is the cricket captain of India, and things like that. So propositions are statements which are either true or false. So if A and B are two propositions, the combination A and B is true means that A is true and B is true, and that's written in this way as A and B. This is very basic stuff, and most of you must have studied it, but this is just to get everybody back on the same page. Similarly, A or B is true if either A is true or B is true. So only one of them have to be true for A or B to be true. So this is written as A or B with this notation. Now comes the interesting part. Suppose we have a rule that says if A, then B, which is the same as saying if A is true, then B is true. The kind of things that we've seen before. If X is the president of C, then X is a leader of C, or the leader of C. Well, the really important part about logical reasoning or classical logic is that saying that if A then B is exactly the same thing as saying that either A is false or B is true. Now, this requires a little bit of thought, which can also be written as A implies B is equivalent to not A or B, which is just the same as A is either false, which is not A being true, or B is true, which is just B. Let's go through it again. A implies B is the same as not A or B. Very important, critical aspect of reasoning. Let's check it. If A is true, then not A is false. So the only way that not A or B can become true is if B is true. In other words, by stating that not A or B is true, we have arrived at a situation that whenever A is true, B has to be true, which is exactly what we meant by saying A implies B. On the other hand, if A is false, then not A is true. So the statement not A or B is always true, regardless of B being true or false. So the statement, rather the rule that A implies B, remains true whatever be the value of B in the situation that A is false, which is also fine because a rule must remain a rule regardless of the values that variables take or propositions take. So please go through this argument a couple of times to convince yourselves that A implies B is exactly the same thing as saying that the compound statement not A or B is true. We were dealing with statements or propositions which were essential statements of fact and nothing more or less than that. But as we have seen before, we are dealing with statements which are a little bit more complicated. Obama is the president of USA is actually stating a relationship between an entity Obama and another entity USA, and that relationship is that one is the president of the other, which could be written in this form, that Obama is the president of USA. Now this is a rather tricky notation, but all we're saying is that we have variables which are entities like Obama in USA, and we have predicates, which are relationships between these variables or entities. Similarly, we might have a rule which says that if X is the president of C, then X is the leader of C, which could be stated as if X is president of C, then X is leader of C. Now, unlike this particular statement on top, the statement about X and C applies for all values of X and C. So this rule is not a simple rule such as Obama is president of USA. It's a statement about all possible X's and C's that says if X and C are related by the predicate is president of, then they are also related by the predicate is leader of. So this particular feature of predicates and variables is called quantification, and that makes it significantly different from basic propositional logic. Still, the process of reasoning remains quite similar with a few modifications. So let's go through that a little carefully. Starting with a fact, such as Obama is president of USA, which is expressed as a predicate, is president of Obama, USA, together with this rule, which states that for all X and C, if X is the president of C, then X is leader of C. Using R and F, we come to the conclusion that Obama is leader of USA. In other words, this new fact is leader of Obama, USA is entailed by the rule R applied on the fact F. Notice a few things have taken place here, that the variable X has been bound to a value Obama, the variable C has been bound to the value USA. So the rule which applies to all values of X and C is combined with a fact by binding the variables to the specific values that they take in a fact, like F. Now, in response to a query, which could be expressed as is leader of X, USA, where USA has been fixed or bound, but X remains variable, one could look at the bunch of rules and facts that one has in one's collection of knowledge and try to answer this query by reasoning, which is essentially answering by deriving new facts which match the query. And we do this by a process of unification, which is binding different possible values of the variables to X, and inference, which is essentially applying rules using the if A then B format to derive new facts. The combination of unification and inference is called resolution, and we'll return to resolution in a little while. But notice that the process of reasoning in predicate logic is fairly similar to that if you just had propositions, with the additional complication that we have variables which need to be bound to different values, and if you have lots of facts and lots of rules, you have lots of different choices for how we bind different variables to different specific values, and that leads to a degree of complexity which makes predicate logic resolution much more difficult than simple logical inference using a bunch of propositions. Both are quite difficult, as we shall see during our discussions later in this lecture, but one is significantly more difficult than the other.